Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to have the input or the concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to go ahead. Anyways, the agenda behind today's video has been very precise and clear. As you can see over the digital board, we are going to take few number of basic problems based on the concept of the probability. Day before yesterday, we have come till question number 4. We have come till question number 4. Probably the fourth question I did not solve in day before yesterday's class. I just gave this question as a assignment. So may I know how much answer we have got it for the question number 4? Once we are done with the question number 4, no, we would start our today's lecture from the question number 5 onwards. And obviously they have been the word problem based on the concept of the probability. If you will focus over the question number 4, this problem have appeared in GATE instrumentation year of 2006. The problem was framed by IIT KGP, Kharagpur. Yes, what the problem states? Two dice are rolled simultaneously. The probability that the sum of the digit on the top surface of the two dices are even is. The four different options were attached along with this problem. It starts with 0.5, 0.25, 0.167 and goes till 0.125. Tell me what would be the best most answer for this given problem. Baba ka gyan, hello dear Pranali Ingle, good evening dear Pranali Ingle, perfect, that's fine, no? Okay, go ahead with the first question of the day and in sequence is gonna be the fourth question. Let me bring this problem towards working board and there we would try to smash this problem out. Yes, the answer have come from the Pranali. According to the Pranali, the answer would be 0.5, which is utterly correct. Let me focus over the crux behind this problem which has been involved. Here it starts solution. Let me read this problem carefully and we'll try to decode all of the informations which are given or which has been associated with this problem. Two dice are rolled simultaneously. What does that mean of it? That means we had the two fair dice. How many outcomes we used to have the individual outcomes? The 6 individual outcome we have with each and individual fair die. So now they have been rolled together. How many possible outcome you will be having? 36. How? 6 is going to get multiplied with 36, which we have already discussed in the last class, from where the 6 and 6 becomes 36. From the concept of tree, we could know about it. Just a minute. Let me switch off my phone. It is unnecessarily making the sound. So what I am saying, so it has been clearly given along with this problem. Two dice are rolled together. Two dice are rolled together. May I know how many possibilities you will be having? 6 into 6, that is a 36. That's a 36. Could you understand what I am saying? And keep in mind, once you will throw the die, no, one could be even, one could be odd, one could be odd, one could be even, odd. Put together, total 4 different possibilities you will have. How many? Total 4 different possibilities you will have. Let's take this has been your first die, this has been your second die. The possibilities could be, you had even over here, you had even over here, you had odd and odd in both of the trial, you had odd and even, you had odd and even, and you had even and even, even and odd. Keep in mind, if the even and even got added, because we have been talking about their addition, the result would be even. Yes, if odd and odd is being added, the result would be even. If the odd and even would be added, the result would be odd. So out of 36 outcomes, half of the outcome would lead even and half of the outcome would lead odd. So you can see, you can try by yourself. Out of 36 different varieties of the outcome which you are going to get, out of that the 18 would lead the even and 18 would lead the odd. And as far as the problem is being concerned, in problem it has been categorically said you had to have a situation where the outcome has to be even. So may I know what would be its probability? So basically you have been talking about the probability that the sum must be even, and that would be P, probability for sum to be even is equals to of total number of events in your sample space or total number of possibilities. How many possibilities you will have? 36 possibilities you will have, and out of 36 number of possibilities, 18 number of events in your sample space is been your favorable event because they have been leading sum as 18. So as far as the answer is being concerned, it has been 1 upon 2. That means half would be even and remaining half would be odd. Remaining half would be odd. So as per the Aniket, yes, Aniket, perfect. The answer has been A. I could have taken the second methodology. May I know what? If you really want to have the sum as even, there is only two scope. What? The first trial had been odd, and the second trial has also led odd, or the first trial has led even, and second trial has also led even. And there is no opportunity apart from these two conditions. May I know how many different odd numbers you'll have once you'll throw a fair die? Obviously 3, that are 1, 3 as well as 5. So you can say if you'll satisfy the requirement of a trial to be odd, that could be 3 out of 6. 3 out of 6. And the same thing goes with a second trial. My dear friends, the outcome in second trial is completely independent from the outcome in first trial. Whatever data comes in the second trial is nothing to do with the data which has come in the trial 1. So keep aside. Now we have been focusing the probability that the odd number would come as a phase while throwing the die once again. So how many possibilities will have? Again 3 out of 6. Here also it's gonna be 3 by 6, and here also it's gonna be 3 by 6. Once you'll multiply them together, it's a 1 by 2 into 1 by 2. Obviously here it would be 1 by 2 which has been raised to the power of 2. Again it had been 1 upon 2 which has been raised to the power of 2. 1 by 4 would get add together, and obviously the answer would be 1 upon 2. So you can say this has been my first method, this has been my first method, and this has been my second method. This has been my second method, and in both of the cases the appropriate answer which we are supposed to get, it's been 0.5. It's been 0.5. So I don't find any of the student would have any sort of doubt. Either you could have used the first methodology. There I have consolidated all of the outcomes, total 36 outcomes we had, and among them the 18 number of outcome would satisfy your requirement, whose sum would be even in nature, and remaining 18 is not going to satisfy your requirement. Their sum would be odd. So it's going to be 18 divided by 16. Otherwise you could have done the problem in this way also. Yes, I was unnecessarily doing the favorable events. Could you understand what I'm saying? So obviously I know many of the students could have done or may have used a different methodology. They could have taken 1, then comma 2, then comma 3, and they would look into whether their addition has been even or odd. So in that way, you are going to spend huge amount of unnecessary time. So that is what I am saying is this problem is not easy, but the student who would try to crack this problem manually, probably they are going to spend around 3 to 4 unwanted minutes over this question. Sir, I used the second method. That's fine, no? So Hangi, that's perfect. So till this point, I don't find any of the students would have any sort of doubt, and I would suggest the second methodology was the better methodology in compare with the first, because there also you had to think a lot, like even, odd. Many of the students may get a little bit confusion in between, and once you get the confusion related to the problem of probability, there it becomes very difficult to get the appropriate most answer. Anyways, keeping aside each and every agenda, the answer for this question has been A. Sir, why you multiply? That I have taken, no Manju, just try to understand. Odd and odd. Why odd and odd? Until and unless you don't get odd in first as well as you don't get odd in second, you will not be able to add them together, and until and unless you will not be able to add them together, you will not be getting the sum as even. Yes, no? So here it has been mandated that you had to have an odd in first trial as well as in second trial. So here and do come while phrasing the sentence like odd and odd, or even and even, or I can say odd in first trial and odd in second trial, or even in first trial and even in second trial. So wherever the odd do come, the multiplication is getting taken place, and wherever the or do come, addition used to be taken place. Manju, I don't find now you will have any sort of doubt now. So can I presume that everything is perfect? Probably everything is perfect. Yes. In the same sequence, now it's the right time to take the next question. It's not a difficult question, but yes, requires a bit amount of thought process. The problem has come, or the problem has appeared in year of 1998. The problem was framed by IIT Delhi. The probability that the two friends share the same birth month is 1 by 6, 1 by 12, 1 144 and 1 divided by 24. You can take your reference itself. Definitely you will have one friend in your life. You can thought of the probability or the problem based on the probability. What is the probability that you and your friend, let's take your name is Neha and your friend's name is Rahul. So what's the probability that you both are sharing the same birth month? You have been sharing the same birth month. Tell me, what would be the best most answer for this given problem? Let me bring this problem towards working board and we would try to smash that problem out there itself. The problem has appeared in year of 1998. The problem was framed by IIT Delhi. This has been the problem. This has been the problem. So yesterday you started Bayes theorem. That's what I am saying, no Manju. That was recorded lecture and I have seen many of the students had the problem in between. That is why deliberately I have started from the basics itself. And probably day after tomorrow I would come back over the Bayes theorem and straight away I would be taking few number of problems based on the concept of Bayes theorem. I know that. बाबा का ज्ञान प्लीज अपने प्लेलिस्ट का एक लेक्चर बिल्कुल बना देंगे, आज ही बना देता हूँ प्लेलिस्ट. I think one more student has suggested why don't you make the playlist for the EMFT. So I did yesterday itself. So definitely for the mathematics probably if time permits today, otherwise max to max tomorrow I would make a playlist. So it would be handy to use. Read the problem carefully and try to get its best most answer. What this problem states: only 5 to 6 number of words are being attached along with this problem and it is being asking the probability that the two friends share the same month's birth. May I know what would be the answer for this given problem? Here starts the solution. As per the given problem, what are the different possibilities which would be accounted under the favorable conditions? The possibilities could be Neha as well as Rahul both had the birth month on January. That's the January and January, or both had been sharing the same month. That means they might be sharing the same month on February. So here it goes like Feb and Feb plus of here it goes March and March, so on and so forth. You can say Jan and Jan, Feb and Feb. How many this terms you would be having? The 12 number of different terms you will be having, and each and individual terms are going to carry the same value. May you know what it is? 1 divided by 12, 1 divided by 12, and their multiplication is being 1 divided by 12, which has been raised to the power of 2. How many terms you had? The 12 number of terms you had. Once you add them together, it would become 12 divided by 12 to the power of 2. End of the day, the result is going to be 1 divided by 12. 1 divided by 12. Could you understand what I am saying? So what I am saying, at very beginning, the two friends we have taken, let's take the friends were Neha and Rahul, and as per the requirement, both should have the same birth month, or they must be sharing the same birth month. The possibilities could have been Neha has born on January and Rahul has also born on January. Keep in mind here dot would be prevailed because we have been talking in terms of and whenever the and phrase is being used over the sentence, by default multiplication do come into the picture. In mathematics we have seen why in previous lectures. Agree? Or why I am saying or, even both have been born on February, then also it's fine. Feb and Feb. What does that mean by the Feb? The Neha has been born on Feb, and even the Rahul has also born over the Feb. And this process would go on, and one of the best thing regarding the terms which has been involved here as here, they have been equal weighted. Why? Because the probability that the Neha had born on January would be 1 upon 12. Bhai, the Neha could have born on January, February, March, April. It is equiprobable. So obviously the probability that the Neha would have born on January had been 1 upon 12, and even the Rahul had born on January has been 1 upon 12. So they would share the same value. How many terms you will be having? Obviously 12 number of terms you are going to have. What's the probability that the Neha must have born on January? It's simply going to be 1 upon 12, and this factor is also precisely going to be 1 upon 12. Here it goes, just a minute, here it goes 1 upon 12. How many terms you had? precisely 12 number of terms you had. And one of the best thing regarding this problem, the problem is not that hectic problem while doing its mathematical analysis, because all of the terms has been quite similar. So what I am going to do over here, you can do one thing, 1 divided by of 12, which has been raised to the power of 2. How many times it has getting repeated? How many times this terms has been started repeating, getting added? 12 times. So end of the day, the probability that the Neha as well as Rahul have been sharing the same birth month had been 1 upon 12. Has been 1 upon 12. Easy problem, but the problem most of the students would not be able to smash. So would like to ask from each one of you, could you really understood the crux behind this? If it is yes, just write yes over the live chat, so I'll have a fair idea that you could follow the concept behind this particular problem. You could follow the concept behind this particular problem. Yes, no? Anyways, I would try to have 3 to 4 more lectures over the word problem based on the concept of probability, because the practice is only the sequence, or the practice is the only way where you can strengthen your concept of the probability. You can strengthen your concept of the probability. Otherwise, my way of teaching probability used to be different. I used to go with the theoretical understanding, then only I come to the practical understanding, but that's fine. No, that's fine. We are trying to bind up all of the concepts with a minimum amount of hour which we will spend together. That is why straight away we hopped into different numerical problems, and we are trying to learn the important concepts of the probability with the help of problem itself. So with the 3 steps, we could get the answer for this given problem. Yes. In the same sequence, now it's the right time to take the next question. Here comes the next question. The question is almost semantic to this. And now we have come to the question number 6. So let me bring this problem towards the working board, and then we would try to smash that problem there itself. So this has been the question number 6. This has been question number 6. Yeah, Manju, I will try. Even one of the best design problem has appeared in year of 2021 electronics, where until and unless you do not have the fair idea about the 3 structure within the probability, you would not be able to smash that problem out. So I'll do one thing. I would try to explain the concept of tree within the probability by taking that problem itself. It is a utterly well designed problem. Anyways, focus back over this problem. What the problem states? The problem states the 7 car accident occurred in a week. What is the probability that they all occurred on same day? They all occurred on same day. May I know what would be the best most answer? The same concept has to be used, the concept which we have used in just last problem, which was the question number 5 in the sequence. Tell me what would be the best most answer for this given problem. Tell me, and probably you do not exactly require the calculator, pen or copy for giving the proper most answer for this given problem. Tell me, what would be the best most answer for this given problem? I would like to have the input from each one of you. What would be the best most answer for this given problem? So what has been the crux behind this problem? We had the 7 car accident. I wanted to have the probability that they have taken place in the same day. So the answer has started coming. According to Aniket Sahu, the answer is B. Anyone else apart from Aniket? Anyways, come back to this problem. This has been the solution. Nowhere it has been given that they have been dependent event. Even the situation could have been taken place that the 2 car has been collided to each other, and if they have been collided to each other, it would become a dependent event. Nowhere it's been given. So I would presume 1 car which has been tuk chuka hai, somewhere it has been collided, and similarly the second car has been collided somewhere else. They have not been dependent in nature. They have not been dependent on nature. So as far as the crux behind this problem is concerned, the basic fundamental which I would be using before solving this problem, one thing has been sure, I have assumed the collision of a first car and the collision of a second car has been independent. Let's take it has been taken place somewhere in Singapore, it has been taken place somewhere in Coimbatore. Could you understand? And now they are completely independent in nature. May I know what's the possibility that they might have been collided in the same day? The same way we have done the last problem, we would be doing this problem. Let's take, we have taken the reference of first car which had been there in Singapore and the second one somewhere in Coimbatore. Yes. The possibility could have been both could have collided by somebody say at, let's take Monday, or the car which were there in Singapore, the car which were there in Coimbatore, they have collided on the day of Tuesday. So you can say Monday and Monday, or Tuesday and Tuesday, or Wednesday and Wednesday, so on and so forth. The important thing is that whenever the or do come into the picture, addition would be taken. Whenever the and do come into the picture, multiplication would be taken. How many terms you had? Exactly 7 number of terms you have. And if we'll talk about the probability that the Singapore car as well as the Coimbatore car has been collided by somebody else exactly on Monday and Monday, anyways, the probability that the car could have collided on Monday is been 1/7, and it has been quite independent from the collision from Coimbatore. How many terms you had? They have been like term. The 7 terms exactly you have been had. So here it goes, 1 divided by of 7 which has been raised to the power of 2. That is what it is. And here something mistake had been done, no? Just a minute. How? 7 cars, sorry, 7 cars they have been. Sorry. 7 cars they have been. Sorry, the mistake had been taken place. The calculation which we have been doing, no, that has been the calculation. If we wanted to have the 2 car collision has been taken place in the same day. Let me finish this problem first. So, how many terms you will be having? 7 terms you will be having. All of the terms are having the same weightage in nature. So end of the day is gonna be 1/7 to the power of 2, which would get multiplied with 7. The result would be 1/7. In the same sequence, let me give a trial to the problem itself. Here the 7 different accident had been taken place. That means instead the 2 number of cars which had been taken place in Singapore and Coimbatore, now you can take the 7 number of cars which has been taken place in Raipur, Kolkata, Bombay, Madras, so on and so forth. May I know what would be the possibilities? The first car which has been or which has met to the accident on Monday, what would be its probability? 1/7. And for the second, 1/7. And for third on Monday, it's gonna be 1/7. It's gonna be 1 divided by 7 to the power of 7. How many days you can have? 7 number of days you can have. Once you'll add them together, simply it had been 7 divided by 7, which has been raised to the power of 7. The result would be 1 divided by 7 to the power of 6. 1 divided by 7 to the power of 6. Agreed? Even this problem could have been extrapolated. If I would design this problem, what I would say, rather giving 7 number of cars, rather giving 2 number of cars, precisely I would say I had the n number of cars. What had been their possibility that they would be meeting to the accident exactly at the same day. In that case, what happens? 1/7 into 1/7, how many times it would come? N number of times it would come, where the n had been the number of cars. So what I am saying, even this problem could have been replaced with the n number of cars also. Because whenever the people would try to solve where the number of cars itself are not predefined, no, many of the students would try to quit that problem itself. So here what's happening, number of car is being clearly given. Number of car has been given as small n. So here what happens, in individual term you will be having the presence of 1/7 n number of times. So it has been 1 divided by 7 to the power of n. And how many days you will be having? 7 number of days you will be having. So end of the day you would be getting 7, or you can simply say 1 divided by of 7 to the power n minus 1. Like in case of 2 car it was 1 upon 7, and similarly in case of 7 car it was 1 upon 7 to the power of 6. 1 to the power of 1 divided by 7 to the power of 6. So this has been the crux behind this problem, and this problem has been appeared in GATE electrical probably year of 2001. The problem was framed by IIT Kanpur. So this must be clear to all of us. This must be clear to all of us. Is that part clear to all of us? Yes. Now in the same sequence, it's the right time to take the next question. And this has been a problem probably you could have studied, or you would have studied in class 9th and 10th also. But this problem do come repeatedly in GATE, EAC, PSUs, and even in software companies when they used to take the problem based on, or the test based on probability. See what has been the problem. Try to read this problem carefully and try to get the best most answer. It has been a type of MCQ, that means out of the 4 different options which were attached along with this problem, only one option is going to be literally correct option. The problem has been experienced by GATE instrumentation year of 2013. The problem was framed by IIT Bombay. What the problem states? What is the chance that a leap year selected at random will contain 53 Sunday? Will contain 53 Sunday. The options were given as option A was 2 divided by 7. Option B was 3 divided by 7, option C was 2 divided by 3, and the option D was 3 divided by 4. 3 divided by 4. Anyways, let me bring this problem towards working board, and we would try to smash that problem there itself. Here it had been a problem. Tell me what would be the best most answer for this given problem. Let me start the solution from here onwards. Let me start the solution from here. May I know what does it mean by the what does that actual fundamental behind the leap year? Anyways, let me teach a bit about the geography. In our solar system, the sun is being at center. And in elliptical nature, there are several grahas which used to take rotation. Earth is one of them. Let's take, it has been Earth. Obviously, size of Earth is much smaller in compare with the sun. Yes. Now the sun used to have the rotation. At very first sense you can have that Earth used to rotate in its own axis. How much time it takes to complete its own rotation? It takes 24 hours. That's fine. But at the same time, it also takes the rotation along the sun. How much time it takes to complete this rotation along the sun? Keep in mind, it takes 24 hours to complete its own rotation, and at the same time, for completing the rotation around the sun, it takes 365 days and 6 hours precisely. See, if we had the 365 days as well as 6 hours precisely, which was the time taken by the Earth to complete the rotation along the sun, keep in mind, manufacturing the calendar would not be that easy, because in calendar we do not talk about the hours and all, we just talk about the number of days. And our calendars are based on the concept of solar system. Yes, no? And at the same time, the Muslims calendars are designed on the based on lunar systems. Anyways, focus over the solar systems once again. So what they did, they said keep 6 hours aside, and after each 4 years, what would happen? This 6 hour would become 1 day. So what we would do? First year, second year, third year, we would presume they had the number of days which is equals to 365 days. And whereas the fourth year, I would presume first year has been left out 6 hours, 6 hours, 6 hours. Even the fourth year has also been left out with the 6 hours. They would add together and they would become 366 in days. Agrees what I am saying? So if I say the first year, second year or third year, What is precise meaning of first year, second year and third year? The years which are not completely divisible with 4. Non-divisible by 4. Non-divisible by 4. How many days they would have? 365 days would have. And similarly, the year which is completely divisible by 4. The year which is completely divisible by 4. They would add 6 hours, 6 hours, 6 hours in last 3 years, and similarly the preceding years itself, it would become 366 days. It would become 366 days. So if I would say the given year is been a leap year or not, leap means there is a uchal in Hindi, I can say, there has been uchal. So you can see first year, second year, third year, there had not been any uchal, but in fourth year there had been a uchal. Yes, and the uchal is because the 6 hours was cumulatively affected the last year. Cumulatively affected the last year. Till this point, probably each and everything must be clear to all of us. So may I know which year had been the leap year? How do we know about it? Just divide that year with 4. Like if I say the year of 2004 was a leap year or not, just divide with 4. If you'll find its remainder as 0, that means 2004 was completely divisible by 4. So obviously it had been a leap year. And if I'll say how many number of days were there in year of 2004, they were 366. Keep in mind normal year and leap year. So the years can be bifurcated. Years can be bifurcated in 2 parts. First is normal years and the second is going to be leap year. How do we know whether it has been a normal year or not? That given year would be divided with 4. If remainder is not being 0, it's going to be normal year. If the given year is being divided with 4, and if the remainder has been 0, it would be a leap year. How many days they would possess? Here it's going to be 365 and here it's going to be 366. 366. So in this problem, it has been categorically said the year which you have chosen for doing the experiment has been a leap year. How many days that particular year would contain? Obviously 360 days, 366 days that year would contain. That year would contain. So here I can write, you have taken the reference of leap year, leap year, leap year. 366 days it contains. Virtually it can be written as, just a minute, it can be written as 52 n2 of 7. Once you'll multiply them together, you'll get the result as a 364. So still the 2 days is being left out. Now the people would say, why 366 has been written in this way? Because each week would contain the total 7 number of days. So may I know how many times the complete week would get repeated? Obviously it would get repeated 7 times, and still 2 days has been left out. Still 2 days has been left out. Yes, still 2 days has been left out. May I know what would be the structure of the remaining 2 days? There could be anything from the set of Monday and Tuesday, or Tuesday and Wednesday, or Wednesday and Thursday, Thursday and Friday, Thursday and Friday, Friday and Saturday, Saturday and Sunday, Sunday and Monday. How many possibilities you have been left out? 1, 2, 3, 4, 5, 6, 7. Nobody can say, sir, the remaining 2 days could be Monday and Friday. The days would come in sequence, no? So they can't be alternative. They can't be alternative. Yes. Till this point, each and everything is must be clear to all of us. So in this problem, they have been categorically saying what is the probability that the given leap year would have the 53 number of Sundays. May you know which are the different event at which the Sundays are getting involved? Obviously they have been this as well as this. How many total events you had? Total 7 number of events you had. How many number of federal events you had? You have the 2 number of federal events. So here it's going to be 2 divided by 7. Because already 52 number of Sundays, Mondays, Tuesdays, Wednesday, they have already come. You just had to focus over the remaining 2 days. And out of 2 days, if any of the day had been a Sunday, no, so the 52 Sundays is already been come. The one more Sunday would come and it would get added, and total number of Sundays would become 53. Total number of Sundays would become 53. So what had been the best most answer? The best most answer has been 2 divided by 7. Could you really understood behind the concept? Could you really understood the concept behind this problem or not? Anyways, you need not to go into this geography and all, but at least you should have one idea that the leap year is a year where the number of days raised from 365 to 366. 365 to 366. Would like to ask from each one of you, this concept is clear or not? Yes. And even the problem could have been changed a bit. Rather focusing over the Sunday, they could have focused on the Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So only one change they could have placed over here. May I know what it is? Rather focusing over the Sunday, they could have focused any other day. But still the answer would not change. If you have been focusing over the Monday, no? If you have been focusing over the Monday, still there had been the 2 Mondays out of the 7 number of events. Out of the 7 number of events. So may I know what had been the best most answer? What had been the best most answer? The best most answer is going to be 2 divided by 7. 2 divided by 7. Now in the same sequence, if the problem had said like you should have 53 Monday and let's take Tuesday. That means the Monday should also be 53 and Tuesday should also be 53. That means one thing has been quite sure. 52 number of Mondays and Tuesdays are already being come, but remaining extra day, Monday and Tuesday should come out of this outcome. Should come out of this outcome. May I know what does the mean of it? Now here you had to take a Monday as well as Tuesday for sure. So you have been left out with only one possibility out of 7 possibility. So rather giving the problem that we have been focusing over the 53 number of Sunday, if they have been focusing over the 53 number of Mondays and Tuesdays, there you can't take this as well as this, because here the Tuesday has been common, and once you take both this and this, only Tuesday has been raised to 53, but still the number of Mondays has been 52. Could you understand what I'm saying? Could you understand what I'm saying? So obviously the answer has started coming. As per the Aniket Sahu, the answer has been 1 upon 7. As per the Pranali Ingle, the answer is 1 upon 7. 1 upon 7. Yes. And similarly, in the same way, they could have asked, what is the probability? What is the probability? I would like to ask from each one of you. If they are changing this problem a bit, nothing has changed. Still, you have been in search with the 53 number of Sunday. What is the chances that a non-leap year, rather referring the year as a leap year, now they have been referring the year as a non-leap year. May I know what would be the possibility that you would be having 53 number of Sundays? What would be the possibilities that you would be having 53 number of Sundays? In case of non-leap year, you would be having total 365 days. You would be having total 365 days. And once you have total 365 days, the bunch of 7 would get multiplied with 52. That means total 52 weeks you will be having within that, and it would just get added with 1. That means you have been left out with only and only 1 day. You have been left out with only and only 1 day. That could be anything: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. How many number of events we have over the sample space? 7 different events we had over the sample space, and now we want to have our Sunday to be 53. Our Sunday to be 53. Already 52 Sunday have already come, and now you want the situation that in last trial that selected day must have been Monday. Out of how many? 7. So it would be 1 upon 7. 1 upon 7. Obviously, almost all of these students are going to give the proper answer. That's fine now. So the answer is going to be 1 upon 7. So I would say the problem related to the leap year, most of the students would be able to address from here onwards. Here onwards. It's not a difficult problem, but requires a little bit basic understanding of the leap year, non-leap year, divisibility rule with the 4, non-divisibility rule with the 4, and similarly the package of 7 and the remaining days would decide the probability of the occurrence. Probability of the occurrence. Yes. In the same sequence, we are focusing over the last question of the day. This would be the last question of the day. Yes, this has been the question number 8. This has been the question number 8. This problem was experienced by GATE Computer Science year of 2014. The problem was framed by IIT Kharagpur. IIT Kharagpur. What the problem states? The probability that a given positive integer lying between 1 and 100, including both 1 and 100, is not divisible by either 2 or 3 or 5. Either 2 or 3 or 5. It's not divisible by either 2 or 3 or 5. Focus over this problem and try to connect with the basic most property of the mathematics. Either you can connect with the LCM or HCF. LCM or HCF. Read this problem carefully and try to get the best most answer for this given problem. The problem states the probability that a given positive, just a minute, the probability that a given positive integer lying 1 and 100 both inclusive, that means while watching you had to include 1 as well as 100, is not divisible by 2 or 3 or 5. 2 or 3 or 5. Tell me what would be the best most answer. What would be the best most answer? What would be the best most answer? And once you are done with the answer now, you should also write what had been your approach while solving this problem. So we had to choose a number which is not at all divisible by even 2, even 3, even 5. Would you be able to get this answer? Tell me. Would you be able to get this answer or not? What would be the best most answer for this given problem? What would be the best most answer for this given problem? Wait, sir. Definitely waiting, guys. Waiting. Although the nature of the problem was a bit different, still I have changed a little bit text formation within this problem just to make this problem difficult. As I was discussing day before yesterday, if you are not comfortable while calculation from one side, do that calculation from other side. Like if you'll focus how many numbers which were not divisible by 2, 3 and 5, that calculation would become difficult. So better to focus over the number which is divisible by 2, 3 and 5, and then the probability would be taken place and 1 would be subtracted out of it and you will be getting the answer out of it. So the answer have started coming. Aniket says the answer has been 0.97. Subhangi says the answer has been 0.97. Anyone else apart from Subhangi and Aniket? See what has been happening. So here starts the solution. First focus over the divisibility of 2. As far as the number which starts from 1 and goes till 100, how many total integers we had? That has been 100 minus of 1 plus of 1, and that is nothing but the 100 numbers we'll have. Yes. Out of 100 numbers, how many numbers which have been divisible by 2? Obviously precisely 50. Because 50 numbers would be odd number and 50 numbers would be even numbers. That is fine, sir. 50. So here it goes, divisible by 2, no? Divisible by 2 is gonna be 50. That's fine, sir. Yes. Otherwise, you can simply calculate how many numbers you have been getting. That's also okay. That's also okay. Next. Next. Divisible with 3. Divisible with 3. How many numbers you will be having? How many numbers you will having? See. 3, 1, ja, 3, 3, 2, ja, 6. If you'll go into the 33 times, 33 into 3 is gonna be 99. So how many numbers you will be having when between 1 to 100, which would be completely divisible by 3? 33 numbers will be having. 33 numbers will be having. Yes. And similarly, if you'll focus over the divisible by 5, how many numbers you will be having? So it's gonna be 1 to 10, that's a 2. Similarly, 11 to 20, that's a 2, that's a 4, 4, 4, or put together you can say 100 divided by a 5, 20 numbers you'll be having. 20 numbers you'll be having. 20 numbers you'll be having. Yes, till this point I don't find any of the student would have any sort of doubt now. But still there are a lot to learn. Because there had been the few of the numbers which has been included within the divisibility of 3 as well as divisibility of 3. Like 6. 6 has been a number which has been included within the 50, and similarly 6 has been the number which has been included within the 3. Not only that, even 30 had been the number which has been included within the 5, 3 as well as 2. May I know how did you get the answer? Deliberately I have changed this problem. Still, I would like to have the input from each one of you. How exactly you could calculate this answer out? Tell me. आप लोग क्या तरीका यूज किए इसको सॉल्व करने का? That I would like to have over your chat box, because I wanted to explain the concept of intersection with the help of this problem. I wanted to explain the concept of intersection by this problem. May I know, straight away manually you could calculate all of the numbers, or you did something else? Sir, I took LCM as 30. So 30, 60, 90 where outcome. So outcome not divisible by 2, 3. Huh? What is that? Sir, I took LCM as 30, so that what I am saying, by nor or, yes, by either 2 or 3 or 5. Yes, okay, that is also okay. Yes, LCM, perfect. But what I am saying, this problem I wanted to explain by the different way. See what I am saying, that is also okay. The people have taken the LCM 235. What has been the LCM over here? They did not have any of the common components, so obviously they would just get multiplied. It would become 5 3 that is a 15 into 2, that is a 30. So it's going to be 30, 60 and 90. They have been the number which would be precisely divided by 2, 3 and 5. Yes. That is also fine. And now end of the day, what you guys are doing, yes, that is also okay. You could have solved this problem by this also. 97 divided by 100. 97 divided by 100. Yes, no, 97 divided by 100. That also is a complete method. But what I would do, I am not going into the detailed analysis, at least with this method. This is called the method of intersection. And this has the 3 different events, and whenever you use to deal with the 3 different events where the intersection do also come to the picture, that problem becomes very difficult. Yes. That's fine, no? The answer would be very simple. So do one thing. This concept I would be keeping for the tomorrow's class. And yes, it has been a very important one. Yes, it has been the very important one. Now you do one thing. Take one problem as a homework. The probability that a given positive integer lying between the is divisible by either 2 or 3 or 5. Now it becomes a perfect problem. Or that means if it is divided by 2, then also okay. If it is divided by 3, then it's also okay. If it is divided by 5, then also okay. If it is being divided by 2 and 3, then also okay. 3 and 5, then also okay. And 2 and 5, then also okay. In that case, you had to go through this long process. Then in that way, you had to go through this long process. May I know what would be the answer for this given problem? I would like to have the answer for this problem now. That must be either divisible by 2 or 3 or 5. May I know what would be the answer? In that case, what you had to just try to understand. You would say how many numbers you had been divisible by 2, that has been 50, 33 as well as 20. But once you'll add them together, no, you will see how much addition had been. 50 plus of 33, that's gonna be 83. 83 plus of 20, that would become 103. 103 number of favorable cases out of 100, and this value would go beyond 1. What does that mean of it? That means there were the few number which were the part of divisibility with 2, divisibility with 3 and divisibility with 5. That has to be taken out, that has to be extracted out. That has to be extracted out. Could you understand what I am saying? So would like to ask from each one of you, would you really be able to understand, or would you really be able to smash this problem out or not? This would not be straight away this, no. There would be the few numbers which would be common here as well as here. There would be few numbers which would be common here as well as here. There would be few numbers which would be common in all three. May I know how will you solve this problem? How will you solve this problem? Would you like to solve now only, or would you like to try this problem in your home? Tell me. Would you try to solve this problem now only, or would you try to solve this problem in your home? Tell me, how will you do this? How will you do this? So this would be your homework. This would be your homework. And yes, it is a very well designed problem. Yes, it would be a very well designed problem. Sir, can we take prime numbers? Prime numbers. No, who said? Prime number is a number which is divisible by 1 and by itself. So in future, if you will take the prime number, the 7 is not the number which is divisible by 2, 3 and 5. No, don't take that. Don't take that. No, Pranali, actually now I had to go for the next class also. And this problem requires a good amount of thought process. Good amount of thought process. So do one thing. Before coming or before tomorrow's class, at the very beginning, I am going to take this problem and you have to do it in your home itself. Okay, then this is all about the today's class. We are going to meet in the next video the person who have been following me over the live application for electromagnetic field theory. Bye bye, take care, good night.